Thank you, Miguel, for the introduction, and thank you so much to the entire SAIR team and UCLA for hosting this. It's incredibly important to be bringing us all together, as was said by Miguel at this time, and so it's an amazing opportunity to be here. So I was told 3 to 5 minutes, and I do read my emails, so I'm going to try to stick to that. So I'll start with a quick introduction to the science that I do. I'll talk about what our Data Science Institute at Brown does so that you have a sense of what people are doing in education. Then I'll talk about what I think is really the frontier for thinking about AI and how education plays into that. So my expertise is really in computational science. So whenever some of my deans speak, they always have to remember what department I'm actually in. So as some of us, I was trained as a computational scientist first, in other areas of science perhaps second. So in the first area of science, I work on ML for quantum computing, and that works in both ways. So the answer to your question is I'm bearish and bullish, a superposition of both. At the same time about doing this. So what we try to do is we use quantum computers to train machine learning models so that we can understand how chemistry and materials actually function. And so we actually do use real data from quantum computers to do this. Again, on the bearish side, I'll say, error bars on quantum computers, if we're honest, are rather large. If we're a little bit clever, they get smaller. But we can use those to train machine learning architectures. And the idea there is really that if we want to model things like quantum materials or bioenzymes, inorganic enzymes that have incredibly complicated chemistry, we do need very accurate quantum answers. And the fact of the matter is, as clever as maybe I am or other people are, that just doesn't happen on classical computers right now. And so we are trying to develop some of the first quantum computing methods to give us those answers and train force fields to understand things. Our second area is really understanding machine learning for understanding protein and RNA dynamics. What we're interested in is understanding, and this was kind of said earlier, if you have a protein and the protein is moving in different ways, how does that in turn cause disease? And this is very true if you think about proteins that are involved in cancer. Small mutations or modifications change exactly how those proteins move. And that's what actually causes the cancer in the end. And so what we've developed are a series of different kinds of models. And I know someone was asking this yesterday, earlier today. Everybody's been talking about generative AI. We make our own models. We make our own models to understand these things. And that's an important aspect of science. We make our own models to try to predict protein dynamics well into the future beyond different barriers. And lastly, we've spent a lot of time on molecular computing. That is not computational chemistry. What it is we actually make molecules compute for us. And there, AI is extremely important for helping us to figure out how do we store data, how do we map different operations onto chemistry. It turns out that chemistry actually recreates a lot of things that we'd recognize as different kinds of neural networks. So I do all these things, but what I do for most of my day job today is running the Brown Data Science Institute. And so many of our alums come back and they say, data science is so 2000. Why don't you update your name to artificial intelligence or the AI Center? We actually do both. But the reason why we call ourselves the Data Science Institute is that we believe that data actually is a larger topic than AI. AI has been built on data, but data is the foundation. And data is something that unites all of our disciplines. If we go throughout campus and we ask, what data do you have? What data do you have? People have data. Even humanists have data. And so many of our disciplines are built on data. And so that's what we focus on. And really, our mission is to stimulate innovation across the spectrum of different fields. And I want to make it clear what's probably different about us is we really do mean all fields. So we make a joke. My deputy director is actually a historian. You might say, what does a historian have to do with AI? Well, historians are looking at this moment, and they're asking very deep questions about what's going on in this moment. And it's absolutely, it's a historical moment that is ripe for historians, writers, and many others. And so we try to look at how do we bring people together across all of these different fields. And just to give you a couple of examples, yes, we have some of the standard things, but we also have, for example, a Center for Technological Responsibility and Reimagination, where we think about the ethical questions and the historical questions that AI and the current society brings up. That said, what do I worry about? What do I think about? What does our institute think about? And why do we care about this interdisciplinarity? And it's really this interface that I spend a lot of time thinking about in higher ed, but just in general. And I know we've all been skirting around this in different ways. But the point is, we're coming to this synthesis of where humans are interacting with the AIs, and perhaps we don't know how that interaction is going to take shape and what form that's going to be in. As an educational institute, we have to think carefully about this. There are practical reasons. Number one, what are our students going to do? Number two, also thinking about the welfare of our students. So we can have large discussions about what's going on in the undergraduate population right now because we are not necessarily thinking heavily about this interface right now. But also, number three, how is it that we are going to fuse these things together to make both of ourselves, the humans and the machines, better? Practical examples of this from the technical perspective is thinking about how do we put humans in the loop for verification, as was said. Important to me, I'm a computational scientist, but maybe secondarily a physicist or a chemist. I care about interpretability. I want to know how do I understand what's going on? So, Barry was saying this, other people were saying this. It's great if a model can predict things, but if I'm not actually understanding it, that's a problem. And so why do I think that's human-computer interface? Well, humans think in one way. I've been cultured to think about, as a biologist or as a physicist, about different kinds of reasoning. Computers think in a different way, and we have to bridge that gap. So if I'm going to forward, let's say, the field of physics, I have to understand what that AI is actually telling me about physics in interpretable ways, and that's a huge area at this interface. And of course, as a third example, the rise of agentic AI. And this is huge for me in education because what we have typically taught our undergraduates is that they're going to be the expert, right? And they're going to be the only one, of people in the room. But now we're going to have humans with perhaps armies of AIs, or maybe armies of AIs with a few humans. We'll see what that ends up being. But the point is, we're going to be collaborating with machines in new ways. And humans are going to have to be leaders. And they're going to have to learn how to lead not just other humans, but actually, in some sense, machines. And so that's going to be a brand new interface. So all of this, AI is increasing our power, it's increasing our capacity, but it's definitely creating both challenges and opportunities for higher ed. And this interface, this important interface where we intersect, is going to be a place where we have to think deeply about moving forward. Thanks.